Hey, this is Presh Talwalkar. Which quantity is greater, sine of 1 degree divided by sine of 2 degrees, or sine of 3 degrees divided by sine of 4 degrees? This is a no calculator question, and I thank Amit for the suggestion. Pause the video if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. Before I explain the answer, I want to give a brief and simplified history about how the word sine became to be called sine. So it all starts with an archer. Ancient Indians thought about the bow as an arc of a circle. We can then imagine constructing the radius lengths of the circle, and this would be the length of the bowstring. Now, to simplify things a little bit more, eventually they started working with just half the chord and half this length here. Then they worked with circles that had a radius equal to 1. Now the length of this blue line depends on this angle right here. And the length of this was known as ja, which referred to the length of the bowstring. This is the modern equivalent of sine, and this ja was in Sanskrit around the year 500. Now this got translated into Arabic as jiba around 800. Now eventually this came to European mathematicians and there was a corrupted translation. So they took a word which had the same spelling but a different pronunciation, and this word jibe refers to bosom or pocket. Now that word translated literally becomes sinus, and that entered Latin around 1100. Now, interestingly, this length right here was called koja, and of course that refers to the cosine. So with this introduction, let's now solve the problem. One way to work out the problem is to use the product to sum formula. So we need to figure out which quantity is greater. Now, since sine of 2 degrees is greater than 0, we can multiply both sides by sine of 2 degrees without altering this inequality. So we can bring it to the other side. Similarly, since sine of 4 degrees is greater than 0, we can multiply both sides by sine of 4 degrees, and it won't alter which side is greater. So let's go ahead and do that. So the problem is equivalent to comparing the product sine of 4 degrees and sine of 1 degrees versus the product sine of 3 degrees and sine of 2 degrees. So we can now use the product to sum formula. Sine of A multiplied by sine of B is equal to 1/2 of cosine of A minus B minus cosine of A plus B. So on the left-hand side, A is equal to 4 degrees and 1 degrees, so we can substitute into the formula. Then 4 plus 1 is equal to 5, and 4 minus 1 is equal to 3. Now we can do the same thing on the other side. So here, A is equal to 3 degrees and B is equal to 2 degrees, so we substitute in. 3 minus 2 is equal to 1, and 3 plus 2 is equal to 5, so we substitute in. So we've now reduced the problem to comparing these two quantities. Now, we can multiply both sides by 2, or cancel out the 1/2 without altering which side is greater, and we could add cosine of 5 degrees to both sides without altering which side is greater. So we just need to compare cosine of 3 degrees and cosine of 1 degrees. But that's easy to do. So between 0 and 90 degrees, cosine is a decreasing function. Therefore, cosine of 3 degrees is less than cosine of 1 degree. So that means the left-hand side was smaller, and therefore sine of 1 degree divided by sine of 2 degrees is less than sine of 3 degrees divided by sine of 4 degrees. So that's one way to solve the problem. But another method is to use the small angle approximation. So Madhava came up with this interesting series for sine hundreds of years before it was in Europe. Sine x is equal to x minus x cubed over 3 factorial plus x to the power of 5 over 5 factorial minus x to the power of 7 over 7 factorial, and so on. Now this is for x in radians. So if we have a small value of x, then x cubed, x to the power of 5, x to the power of 7, and so on will be very, very small numbers. So this entire part of the sum will approximately be equal to 0. So sine x will approximately be equal to x. So let's use this approximation. Now we need x to be in radians, and we have degrees here. So let's convert these degrees into radians. 1 degree is equal to pi over 180 radians. Then 2 degrees will be equal to 2 pi over 180 radians. So let's just simplify this left-hand side first. Let's use sine x is approximately equal to x. So we have pi over 180 divided by 2 pi over 180. The pi's and the 180s will cancel out. So this left-hand side is approximately equal to 1/2. Doing the same thing on the right-hand side, 3 degrees is equal to 3 pi over 180, and 4 degrees is equal to 4 pi over 180. So this will approximately be equal to 3 pi over 180 divided by 4 pi over 180. The pi's and the 180s cancel out, so we're left with 3 over 4. So the left-hand side is approximately equal to 1 over 2, and the right-hand side is approximately equal to 3 over 4. And so the left-hand side is therefore less than the right-hand side. Now just for fun, we can use a calculator and actually check. So the approximation is actually very good. So that's another way to solve this very interesting question. Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems one video at a time.